Oh snap, back again. Mathematics that never ends. Today is an all new lesson, so get ready. Never seen this before. Yeah, right. Um, Hopefully, you guys find this a little bit easy, but technically, it's all new. This is one of the skills that is going to be important when you move forward into calculus. And we're going to take it slow, of course. So, but you're going to notice a lot of things that you've seen before and kind of old school stuff. So we are looking at sequences, series, and sigma notation. A sequence is a list of numbers where we discuss each number in the list as a term and its position in that list, okay? So we're going to kind of talk about some different things here as we go through. So as you can see here, we've got this list, 3, 6, 9, 12, 15, and it goes to this A sub n. That's how you say that, A sub n. So this 3 here is the first term, so that's the 1 that shows that it's the first term. But what we would call it is A sub 1. That is the actual term. A sub 1 equals 3, okay? And the nice thing is this acts like a function where these position numbers, those go in the function. So if this were a function, f of 1 is equal to the first term, which is 3. We'll talk more about that in a minute, and you're going to be like, oh, why did he say all that dumb stuff when he could have just showed us how to do it? So we've got the position number, first term, second term, third term, fourth term, fifth term. The nth term, you're going to hear that a lot, is what we say for any given term. The nth term, it's that term, it's this term, it's whichever term, 100, 1,000, 1 billion, it doesn't matter. So you would say A sub n, that represents the nth term, any given term. These sequences may be finite with an ending value, or they may be infinite and go on forever. But we're going to restrict it to finite sequences for this lesson. So to define a sequence, you can either have a sequence given, or you can have a formula. An explicit formula gives the nth term as a function of n, okay? Highlight that and say it again. An explicit formula, which is what we're going to be using, gives the nth term as a function of n, okay? What that means is, if I say find the second term as a function, we can plug in 2 into that function, into the formula, to find what the second term is. Again, you'll see what that looks like in a minute. Let's start easy. Find the next 4 terms in the sequence. Okay, find the next 4 terms. Guess what, folks? It's all about pattern. Let's go with the fancy blue color here. Let's see, practice my writing. Blue. Move this out of the way. Okay, so it's all about patterns. How do I go from -7 to -3? I'm gonna add 4. How do I go from -3 to 4? Well, I'm gonna add 7. How do I go from 4 to 14? I'm adding 10. And then from 14 to 27, I'm adding 17. Is that correct? No, that's absolutely not correct. So sorry. I'm adding 13. So as you can see, it's a strange pattern, but a pattern nonetheless. My pattern actually has a pattern. Switching to red here, I'm increasing by 3 each time on my pattern. 10 to 13 gives us the +3. So if I were to find the next 4 terms, think about it like filling in the blanks. I need 1, that's a 2, not the right color. Let's use something you can see now in green. 1, 2, 3, 4 more terms. So what I'm going to have to do is use the pattern on the pattern to find the next term. So from 13, I need to add another 3 here, which would give me plus 16 for my next number. And I'm going to use a calculator. 27 plus 16 is 43. The next number is 43. Then I'm going to add another 3, and now you can start doing things in your head a little bit. So instead of plus 16 from the 43, I'm going to add 19 because I added 3 to that. And 43 plus 19, and I'm just going to use the 43 already in my calculator, plus 19 is 62. Then I'm going to add 3 to 19 and add 21. And 62 plus 21 is 83. Then I'm going to add 3 to 21, and I'm going to add 24. Sorry, I'm getting a little bit off of my pattern format here. 83 plus 24 is 107. 107. Now, so we found the pattern, and we noticed that it wasn't adding the same number every time. So what we did was we found the pattern of the pattern, and we're able to continue the blue pattern. Then we just use that to find the next 4 terms of the sequence. It's a little bit long here. So the nice thing about explicit formulas, as you're going to see, is if I have a formula, it's going to help me out. You might see this right here, find the 6th term and think, oh no, I have to do that 6 times. No, no, no. Remember, it is a function. So what it's saying is find a sub 6. What do you notice? I just replaced n with 6. That's how you find a sub 6. You take 1 over 2 times 6 plus 2, and then you just plug it in. 2 times 6 is 12, and now 2 plus 1 over 12. You guys thought we weren't going to have any fun today, but look at this beautiful fraction work. If we multiply by 12 over 12, we get 24 over 12, which gives us 25 twelfths, would be the 6th term. So the way you would write that is a sub 6 equals 25 twelfths. And that lets us know the 6th term of the sequence is 25 twelfths. Okay, you try this one, or pause the video and then try it. Okay, that's enough time for you. Where's my color that I wanted? There we go. 3rd term, that means we're plugging in 3. So a sub 3 equal to 1/2 to the 3rd plus 3. Use whatever means you have necessary. 1/2 times 1/2 is 1/4. Times 1/2 is 1/8. The ones on your practice may or may not have fractions in them. Who knows? Times 8 over 8 to make it a common denominator, and we get 24/8. Whoa, another 25 on top. Just a coincidence. A sub 3, or the 3rd term of the sequence, would be 25/8. Coolio? Okay, now let's see what comes next. Series. Oops, I forgot to delete my annotations. Series and sigma notation. Sounds fun, right? It is so much fun. Series. A series is a sum of all the terms in a sequence. And what is sum? It means added together. For example, if the sequence was 1, 3, 5, 7, 9, the series would be 1 plus 3 plus 5 plus 7 plus 9. This is why we're not going to touch infinite series today, because we'd have a lot of adding to do. But we will talk about that next time, probably. The nth partial sum refers to how many terms in your sequence you're going to add. So if I had the 4th partial sum, I would add the first 4 terms. And we call it S sub n. So the way we calculate a partial sum is by calculating each term up to that nth term. So if I said the fourth partial sum, I would need 4 terms, and then just add them all together. So hopefully these ones won't be as tricky. Example 4, find the 7th partial sum. Don't pay attention to that down there yet. Ooh, orange, I haven't used orange yet today. 7th partial sum. So right now I only have 1, 2, 3, 4. I need 5, 6, 7. 5, 6, 7. So I have to find the pattern, find the next 3 terms, then add them all together. Okay, we can do this. Negative 22 to negative 10 means I'm adding 12. Negative 10 to 1 means I'm adding 11. Ooh, this doesn't look too bad. 1 to 11 means I'm adding 10. What do you think the pattern is? I'm decreasing the number I'm adding every time. That's not too bad. So for the 5th term, I would add, yes, you guessed it, 9 and 11 plus 9. So don't forget, we're not adding 10 plus 9. We're adding 11 plus 9. We would get 20 here. Then I'm going to add 8 to get 28. And then I'm going to add 7 to get 35. Comma, 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 because that is a sequence. Now, a series is just adding all these things together. So we're literally going to put plus signs between all of these. Add that, add that, add that, add that, add that, add that. It got ugly right there. That's okay. Just use your calculator very, very carefully. And I might do this wrong, so you do it with me and double check. 22 negative plus 10 negative plus 1, which is not negative, plus 11 plus 20, oh, I just got to 0, plus 28 plus 35. 63. So this equals 63 when I add them all together. The 7th partial sum of this sequence that I have is 63. The only reason this would be different is if I had a formula for my sequence instead of the actual sequence. And then to find each term, I would plug it in to find each term of the sequence and then add all those together. And that's what we're going to do next with sigma notation. Okay, get ready. Scoop. Oops. Let's scoop. So sigma notation is just that. It's notation to do exactly what we just did. We have this Greek letter sigma right here. Looks just like an S, doesn't it? No, it's a weird shape. And using this letter is called sigma notation. There's some very important things about this notation. So we've got this sequence, a sub 1, the first term, 2, the second term, a sub 3, the third term, can be written in sigma notation, and sigma notation references the actual sum of all of these terms. The number on the bottom, n equals 1, that is the starting term. Okay, that's where you're going to start. You're going to start on the first term. The number at the top, k, that is the last term. So we're going to go all the way up to that term number. And then a sub n is the nth term. That's going to be our formula right there. And that's going to be nice because that's where we can plug values in. Then we're going to add up all the pieces we get. So this notation literally means adding all those things together. But what we need to do is we need to calculate all of those numbers and then add them together. So the sigma notation does not give me each one of those, but it gives me the formula, which I can use to calculate each one, then add them all together. So a nice long list works really well, as you can see here, for example, 5. Okay, so what I like to do, let's see, how about this light blue color? I'm gonna have to work on my color schemes, color options. So I know I start with 1 and I'm going to 4. So I'm gonna write 1, 2, 3, 4. And don't forget, this is a sub 1, a sub 2, a sub 3, a sub 4. I need to find each of these 4 terms and then add them all together. How do I find a sub 1 when given a formula? Oh, that's right. You plug it in. So 2 to the 1 over 4. I might run out of room here. 2 to the 1 is 2. Divided by 4 is 1/2. Oh my gosh, I'm so excited. More fractions. Let's see. How am I going to do this? Because it's going to get jumpy. I'm going to, tell you what, I'm going to do this. I'm going to erase this stuff, and then I'm going to come back one step at a time. Here we go. A sub, not the eraser, draw. There we go. A sub 2 is equal to 2 to the 2 over 4. 2 to the 2 is 4, divided by 4 is 1. A sub 3 equals 3 squared. Oh, just kidding. Nope, I did that wrong. I'm not changing that 2. I'm changing the exponent. 2, there it is. 2 to the 3 over 4. 2 to the 3. 2 times 2 is 4. Times 2 is 8 over 4 is 2. I'm going to go ahead and write that out. 8 over 4 equals 2. Okay, I'm going to do one more. I'm going to run over my B example here for a minute, and then I'll erase and come back. Okay. A to the 4, that's what I was doing, equal to 2 to the 4th over 4. 2 times 2 is 4, times 2 is 8. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 over 4, hey, that's 4. Man, we didn't have any more fractions. So a sub 1 is 1/2, plus a sub 2 is 1, plus a sub 3 is 2, plus a sub 4 is 4. I'm going to add all those together. I'm going to save the 1/2 to the end. 4 plus 2 is 6, plus 1 is 7. 7 plus 1/2. Multiply that by 2 over 2 and get 14/2. Gives me 15/2. The sum of this series for A is equal to 15/2. So remember, the n sub 1 means start with the first term, or n equals 1. The 4 on top means go to the 4th term. So we need 4 terms, 1, 2, 3, 4. And then we use the formula to calculate each term. A sub 1 plugged in 1 to the formula given. A sub 2 plugged in 2 all the way to a sub 4. And we just took each of those answers and added them all together. You try B while I erase, and then I'll do it. Erasing. It's just like we're in class, you guys. It's so much fun. Erasing. Disappear. Oh, okay. You could also pause it if you want to. I'm going to go back to orange. I don't know why I'm feeling orange today. So this time, we're starting at the 3rd term, a sub 3. And this time, I'm just going to work as I go and not write in all those things because I ran out of space. A sub 3 is equal to 3 squared minus 2. 3 squared is 9. 9 minus 2 is 7. A to the 4th, not a to the 4th, a sub 4. 4 squared is 16. Minus 2 is 14. A sub 5. 5 squared, 25. Minus 2, 23. That's tricky. A sub 6. 6 squared minus 2. 6 squared is 36. Minus 2 is 34. And the last one, I'm going to squeeze in here a sub. Oh no, I'm done. Now, notice this just before we add these together. I started at 3 and I went to 6. So a lot of people think that's 3 terms because 6 minus 3 is 3. 3 3, 4, 5, 6. Tells you which term to start with and which term to end with. Be very careful. But now all I have to do is add all these mamma jammas together. For this, I'm going to use my handy dandy calculator. 7 plus 14 plus 23 plus 34 equals 78. Boom shakalaka. I think this lesson might be too easy. I'm going to have to add some more now. Please highlight any things you didn't understand. Email your teacher so you can get questions answered before submitting your work.